Let me just record this as this workout. Sorry, recording. This is the work for the first examples. And here is the first set of practice problems. You can pause the other slide or rewind it and pause it. I'm gonna go ahead and give you guys 4 minutes on this one. Amen. Remember to put in your answers for the chat for each practice problem class. So that way I can see that you're understanding the work on your own. You're able to get the answer. So Justin got 1 for number 1. Does anyone agree or disagree with that? I will say this, all these 3 practice problems, the answers are negative numbers, guys. So Justin, I will take a look again at number 1, sir.
For 1, I got -29.
Another answer, -29.
I got the same answer.
Okay, so that's 1 agree for -29. Ishmael got -29 again. So Justin, take a look at it. That gave you 1. You want to run through the steps together, Justin, to see how you got the 1 or how to get the -29? So that was the 4-minute timer class. Does anyone need more time to work out 2 and 3?
Yes, sir, I got a question.
What's up?
So on number 3, if you have to solve the brackets first, right?
Yes, but in order for you to get the bracket, Jacob, you have to also get what as well, simplified.
Just the parentheses. So
There you
I
go.
got well, I simplified the parentheses, and then I did like because I know it's you have to multiply the 5 and then the number that you get with the 3 and
Yes, sir, that's correct.
okay, so I got that's 10, and then I did the -6 plus the number that I got,
Yes, sir.
and
Uh-huh.
I got a positive number. I don't know if that's correct.
That's
Just
correct. For
okay,
this part, right? For the bracket part, right?
yes.
So this would be 2. Yeah, it would. Yeah, the bracket will be positive. That's correct.
Okay, and then from there, what do I do? Like, because I got just 3 numbers, I multiply the numbers, right?
So remember, when you have a number next to a bracket or parentheses, what operation is there that we don't see?
Multiplication, correct?
That is correct, sir. That is correct. So then you'll
So
multiply those 2 and then subtract your 7. Because remember, following the PEMDA step, and we multiply before we add or subtract, okay?
oh, okay.
Remember PEMDA, sir? Yeah.
Yeah.
Great questions, Jacob. I appreciate you, sir. Good, good, good. And then all right, Justin, what did you do first, Justin, for number 1? I want to see your what did you do first? Remember, what do we do
Funny
first?
you said that. I was just about to ask you if you could go over 1. What did I do first? I did, hold on, I'm on the wrong page. I did the brackets, parentheses.
Okay,
I did 2 minus 9,
what did you get?
-7.
Good, so that stays there, right? Plus parentheses -12 minus 3. Okay, what'd you do next?
Then I did the -12 minus 3, gave me -15.
Ah, you're going off the order, Justin. You can't.
Huh?
See, you're subtract. You say you subtracted. You said you did -12 minus 3, but subtraction is the last step, sir. What should you have done first?
See, that's what throws me off, to be honest, is like, I'm so conditioned, like, seeing the symbol, but then realizing, wait a minute, you have to follow PEMDAS, not what you see on the, does that make sense?
Yeah, no, it makes sense, sir. But so to get rid of a conditioning that you've been, accustomed to for your life, you want to make sure you get the new techniques that you have, like keeping a checklist there, and make sure you're
Bear
following,
that in mind.
and that you're following this checklist as opposed to just doing it from what you think you should do, because you're gonna naturally just do what you're used to doing. But
Yeah,
now we want to use the new technique that you're learning in this class. So we did parentheses. You're correct on that. What's the next step after parentheses, Justin?
well, there's no exponents, so
You're done
multiply
there.
/ divide.
Is there any multiplication or division?
The 2 minus, the two -7, right?
What's going on there, sir?
You're multiplying there, aren't
Yeah,
you?
so yeah, they are, right? Because yeah, they are. So what's that multiplied?
That is equal to, hang on, let me get my calculator here. That's equal to -14, isn't it?
That is correct.
Okay.
And then how do we finish this off now? Now we're done with multiply. Do you see any more multiplication or division?
You're dividing the -12 by -3, right?
Are you dividing? How do you know? How do you see that? Where do you see the division?
Or hold on, no, you're actually doing the adding/subtracting, aren't you?
Right here. You're talking about this right here, right? Adding and subtracting.
Yeah, yeah. As well as it comes up in the next step, right?
Yeah. Well, you could this when you see a plus and a negative, you have to remember that it simplifies to one thing. What is when you're adding a negative? What operation are we really doing, Justin? When
You're really adding.
when we're adding a negative number, we're actually adding the number. Will the number get bigger or smaller if we add a negative number?
Wait, can you say that again?
If we add a negative number, Justin, will our number get smaller or bigger? When we
Bigger.
when we add a
Oh, no, actually, you said negative. It's getting smaller.
yeah, right? Because negative takes away from us, right?
Right.
So if it takes away from us, what operation takes away?
Takes away the adding and you're subtracting instead.
Exactly, we're subtracting. So I need you to take note of that, and not just Justin, but everyone, class, that when you're adding a negative is actually just subtracting. And we see that again here in number 2, Justin, you see that? Plus a -3.
Yeah.
You see that? Okay. So, all right. So now do we have any more multiplication or division, Justin?
You do not. You have subtraction though,
Yeah, so now we add and subtract from which way to which way?
left to right.
So now we do -14, take away 12.
And that, whoops, is equal to -26.
And then we take away again, well, how much?
3,
And what do we get?
you get -29.
And that is correct, Justin. Good job.
All right.
So remember, do not just start working this problem the way you've been doing it. Do it the way you've learned. Follow create the checklist and just go through each step and make sure you don't skip any. Okay, sir, is that understood?
Yeah.
Okay, all right. All right, any questions on number 2 or 3, guys? All right, let's go ahead and move on. So I'm gonna give you about 2 minutes to set up this example. So I'm gonna read this example. So in this example, guys, we're gonna be doing evaluating algebraic expressions. Example, evaluate the algebraic expression for the given values. So for A, we're gonna do x squared and -x squared for x equals -11, 6z squared for z equals 2 and z equals -2, x plus 2y minus z for x equals 3, y minus -5, and z equals -4. And D 7 minus x squared for x equals -4. All right, let's take a look at example A, guys. So that's giving us two different expressions, but they want us to plug in the same X for each one. So I'm gonna go ahead and do the first one, right? So we're gonna do X squared first, so X squared, right?
Sir, does it matter? Like for example, um. Oh, well, I'll talk about it on B. My bad.
No, yeah, no, do you wanna ask now or you wanna wait for this, for me to work this one? It's up to you.
Oh,
I don't
oh,
mind listening to you now.
okay. So on B, 6Z, it doesn't matter. Like, cause you know how it says for X, for Z equals 2 and Z equals -2.
Yes, sir.
There's only one Z.
Oh, yeah, so what that means is you're gonna do two different plugins for B. We're gonna do we're gonna plug in when Z is 2 and simplify that using PEMDAS. And then we're gonna do a second number and do a whole different separate work for when Z is -2. That's what we're
Okay.
gonna do for B. Does that make sense?
Yeah.
Okay, good. Good question, sir. Good question. All right, let me go ahead and work out A. So we're gonna go ahead and plug in -11 for X squared, right? That's the first expression we're gonna do right here, X squared. So it'll be parentheses -11 squared. So now we have -11 squared. Now what's gonna be repeated? What number is gonna be repeated multiplication, class? -11, right? -11 times -11. Two negatives make a
Positive.
positive. So then we get a positive 121 and we're done. All right. Good, good, good. Do not get thrown off by that. Let me draw a little line here and then get my other color. So now we're gonna do the other expression, negative X squared, right? We're doing this one right here. And now we're gonna plug in, so negative parentheses, -11 squared. Well, luckily, guys, guess what? We already did -11 squared. We know what that is. We know it's 121. But what's still there? The negative sign is still there. So it becomes -121. Now we're gonna go ahead and go for B. So we're gonna plug in, we're gonna do 6Z squared for Z equals 2. That's the first one we're gonna do. Let me switch up my color. So we're gonna do 6Z squared, right? But instead of Z, I'm gonna plug in for 2 squared. That's what I'm gonna simplify first. Remember, we have to do PEMDAS. So am I gonna multiply 6 times 2 first or do 2 squared first?
The 2 square.
2 squared, correct, because we do exponents before multiplication. So 2 squared, 2 times 2 is just 4. So then we get 6 parentheses 4. 6 times 4 is just 24. And we're done with the first one. Now we're gonna do the other one. We're gonna do when Z is -2. So 6 parentheses -2 squared. We're doing the same thing, right? But now it's a different Z value.
So
Exponent.
what
Go ahead, Jacob. What do we do, sir?
is it? -24.
Ah, well, you tell me, sir. Look at the exponent. What's the base? What are we gonna multiply to itself?
-2.
So we're gonna do -2 times -2, right? What's -2 times -2?
+4.
+4. So then it's the answer is still gonna be what? A +24. You see that, sir?
Yeah.
Good, good, good. All right. Let's go ahead and take a look at C, guys. C. So we have an X, a Y, and a Z. So we see that X is gonna be 3. Plug that into that X value there. Oh, crap. They're not meant to do that. So this is the first X one. And then we're gonna go ahead and plug in Y for -5, which is right there. And then we're gonna go ahead and plug in Z is -4. So now let's plug that in. So X is 3, right? So it'll be 3 plus 2Y. Y was -5 minus -4. Now I plugged in every X, Y, and Z. Now it's an expression to simplify like we've done in the first example when we first started this lecture. So now we simplify using PEMDAS. Now, right here we have a minus a negative class. What happens when we minus a negative number? What operation are we really doing when we have-
Positive.
There we go. So that's gonna become a +4. So then we get a +4 Then bring down everything else. And then now we follow PEMDAS. So we multiply before we add. So 2 times -5 is -10. So then I'm gonna get 3 plus -10 plus 4. Uh-oh, but I have a plus and negative, guys. What does that mean? What do I do with this plus and negative? What does that simplify to? What operation?
Negative.
There we go. So you get 3 minus 10 plus 4. And now we add and subtract from left to right. So 3, we have $3, but we spend 10. So what do we owe the bank so far?
-8.
You're off by 1.
7.
There we go. And then we owe 7, right? But we put in 4. So in reality, we only owe how much?
3.
There we go. Good job. All right, last one, guys. D. Am I going okay pace or should I take it? Remember, tell me to slow down if I'm going too fast, guys. I'm not trying to be Speedy Gonzalez here. I'm trying to make sure everyone has class.
You're okay. You're good.
So then 7 minus x squared for x equals -4. D is the trickiest one, class, but I included it here so you can see it, see me do it, so you don't get confused when you see it in the homework or on the test. So let me switch the color up. So we have 7 minus x squared, right? But we know x is -4. So -4 is being repeated. -4 times -4 is a positive what?
4, not 4, hang on.
16.
16.
Yeah.
Oh, what's still there, class? What is still there that has not disappeared?
The minus.
The
The minus.
minus. The minus. I've seen a lot of my students last semester, they would do this right away. They will make it a +4. And I was like, why are you doing that? Well, you always do that in the other examples. I'm like, yeah, but why can't I do that this example? What's next to the 4 that stops me from combining those two negatives to a plus? What is there in the expression next to the 4?
The square.
The square. Thank you, Shirley. Yes. So 7 minus 6. 7 minus 6. We have 7. We spend 16. I think it's -9. Correct me if I'm wrong, class. But yeah. And we're good. Any questions before y'all practice on your own on the next slide before we do your practice problems? Any questions?
So like you were saying on D, since like you were saying, it doesn't cancel to a positive when it's like that. How many times will that happen on problems? Does it happen a lot?
It will. The thing about that, Justin, it could happen. So you need to understand what you're seeing. You need to understand
course.
when you're plusing a negative, it's minusing. When you're minusing a negative, you're adding. You need, as long as you know the difference, you'll be good.
So that's a good reason to read the full thing, because if you don't read the full thing, say when we're doing it on my math lab, you could miss something like that.
Exactly, sir. And the key to lecture, the key to class, reason why we do these practice problems, because I want you to try yourself. Can you figure it out?
Take that to heart.
Okay.
All right, class, I'm gonna go ahead and give you a 5 minutes. on
Take you
the
outside.
problems, okay? 5 minutes. Good luck.
No. My baby. Damn it, fuck. Ow, ow.
All right, 5 minutes started now. I'm gonna go get some water, guys. All right, I'm back, class. Anyone have any questions on it? Remember, put your answers for one, where you need two answers for number one, two answers for two, and one answer for three and four each.
You said two answers for one?
Yeah.
Okay. And what were the other two you said that had two
And
answers?
two different answers for two, and then one answer for three and one answer for four.
Okay. All right. Whoops.
Hey, sir, for one and two, are they both positive numbers? Because I got like the same answer. I
So-
think I did.
Like, you mean like, you're saying like the two answers for number one, you're asking if they're both positive? Right? Is that your question?
Yeah,
So
yeah,
one,
because
go ahead. What did you
I
get?
don't know if I'm doing it right, but number one, I got like 225, but for both of them.
Yeah, me too.
So 225 is correct for the one of them, but the other one should not be 225 or positive. Look, it's just like example A. So remember, we know that when we multiply a negative times a negative, we get a what?
Positive.
What's it?
Yeah,
Oh,
but
okay.
the other expression has a what, sir?
I see what I did.
Yeah, you probably forgot about this other negative sign. You see it?
Yeah,
Okay, good. As long as you catch your mistakes, sir, during class, that's the main thing that matters, you know?
yeah.
I got a question for three since, sorry, I don't know what your name is, brought this up. Is three a positive number?
Is three gonna be a positive answer?
Yeah, that's what I meant.
Yeah, I'll tell you. Yeah, I'll be honest. Yeah, it is positive. It is.
Okay, cool. I got a positive on that.
What'd you get? Positive what?
6.
How'd you get a positive six?
Well, what I did was I noticed you, ugh,
When you
you,
plugged it in, what did you get?
ugh.
When you plugged it in, Justin, what did you get for the expression when you plugged it in?
Well,
What did you write? Tell me what you wrote.
I cannot talk today. Actually, no, I take that back. I got a positive, but I think I have the wrong positive because what I did was, as it says there, y is -3, and I put that in for x, while x is -6.
There you go, sir. So go ahead
So
and
I
make,
was on the right track,
there you
just
go.
the wrong order.
Small mistake. Go ahead and fix it and get it done, okay?
I got 33.
33 for number three. All right, I'm gonna put that there for now till someone agrees or disagrees.
I
So
agree.
excellent. Thank you, Jose. Good. And then we had the 225 for one answer for one. Is there another answer for number one that people got?
Well, I got
Negative
0
25.
as one of the answers, but I could be wrong, of course.
All right, we just need someone to share the answers for two and four.
Is number 4 a negative number?
Is number 4 a negative number? Yes, sir, it is.
I got negative 60.
Negative 16. Does anyone agree or disagree with Jacob's negative 60? All right.
I agree.
Okay, and that's the timer, guys. Are there any other questions on these examples before we move on, or these practice problems? There you go. You got 33. Excellent, Justin. Good job, sir. Are there any questions, comments, or concerns for any of these practice problems, guys? Or would anyone need me to work out any of these?
Can you work out number 1?
Was just about to say that.
Yeah.
Yes, I can. All right, let me go ahead and give me a second. All right, number 1. So number 1's asking us to evaluate x squared and negative x squared for x equals negative 15. So we're gonna do this for 2 different expressions, x squared and negative x squared. They want us to do it for 2 different ones. So x is negative 15, so it'll be parentheses negative 15 squared for the blue. Now, negative 15 squared is negative 15 times negative 15. 2 negatives make a positive, and then 15 times 15 is 225. So that's gonna be the answer for the blue, for x squared, right? So now we have to do it for negative x squared. So it'll be negative, right? It's right there, right? And then it'll be parentheses x, right? What's x? X is negative 15 squared.
Okay,
Now remember, we have to do exponents first. We have to do negative 15 squared first, right? What's negative 15 squared? Well, negative 15 squared, what did we get over here on the blue? It's
you get
2.
negative 225.
We get, well, I'm just talking about the highlighted part.
Oh, yeah,
The orange,
yeah.
that's just positive 225, right?
Right,
But what's still there in front of the parentheses?
the negative.
A negative.
That makes sense because I did get the first half, the positive 225. I just forgot to do the second step.
And it happens. It truly does happen, guys. We tend to overlook some basic steps in our life, whether it be in this problem or in life. We just have to make sure
True.
we're equipped and understand to reflect and look at what we should do differently next time. Any questions on any of the other problems, class? All right, let's go ahead and move on. This is the last slide. I do want you to write the formula that's above here. This is the formula. And then for the example, when you write the example, you can write the list of numbers out and you can just write what it is. You can write that it's the monthly normal temperatures for Barrow, Alaska. And then once you do that, and then write the numbers down, I'll go ahead and work it out. So I'm gonna go ahead and give you guys about 2 minutes to copy this slide.
Do you want us to copy down the graph?
No, you can just write down the numbers that I highlighted in the graph. The numbers are the main important part, sir. All right, class. So now I'm gonna go ahead and get started. So to find the average of something, you have to sum the different items and divide by the number of items we added. So let's take a look at this example. It says the graph shows some monthly normal temperatures for Barrow, Alaska. Use this graph to find the average of the temperatures for the months January through April. So it wants us to find the average from January through April. So January is gonna be -13, -16, -13, and 2. And wants us to find the average of that. So underneath your numbers, you're gonna then draw a little line and you're gonna write average is equal to -13 plus -16 plus -13 plus 2. But we already established in this class, when we have a plus a negative, we know it's gonna be a subtracting problem, right? So I'm gonna equals divided by how many numbers we're adding. You have 1, 2, 3, 4. We're dividing by 4 because that's how many numbers we're adding. So now we know that plus a negative, we know it's subtracting class. So we're gonna go ahead and do -13 minus 16 minus 13 plus 2 over 4. So let's go ahead and then use our calculator. So we -13 means we owe 13, right? We don't have 13, we owe 13. We spend 16. We spend another 13 and we add 2, and in total we spent -$40 divided by 4. When we divide the -40 by 4, it simplifies to -10. So then the average temperatures in those 4 months was -10 degrees. Does anyone have any questions, or what questions do we have regarding finding the average of data?
So essentially, basically, what you're saying is you take the numbers it gives to you, -13, -16, -13 again, and 2, and you always divide it by how many numbers it gives you.
How many numbers we're using? That is
Yeah,
correct.
that's what I meant.
Exactly. So like, for example, guys, in this class, I'm gonna add another slide real quick. So I want to talk about it. So in this class, we have our grades, right? We have our attendance, we have our homework. Our homework is 15% of our grade, right? And the test that we'll be taking is worth 50% of our test. So pretend you get your test, right? Let's say you get a 70 the first test, you get an 80 the second test, a 70 the next test, an 80 the next test, and then let's say you get a 50, right? Life got hard. So then we want to know the average. The average is we're gonna get 50% from the average, 50% of the average. So what we do is we add these all up. And what am I gonna divide by? How many numbers are there? How many tests do we take this semester?
4
5.
or 5, yeah.
1, 2, 3, 4, 5. So 70 plus 80 is 150, and that's another 150. That's 300 plus 50 is 350 divided by 5. This gives us a 70 average. So then we get 50% of this average. So then that we're gonna get 35 points. So 50% of 70 of the average is 35 points. So this is gonna go towards our final grade class. So the higher the average, the more points go to your final grade. So that's how averages are really utilized in real life class, that you want to understand what you do. So like, for example, if you wanted to find the average of every time you go out to eat. So let's say let's use an example. Let's say for lunch, you go out to lunch every day because you have an hour off and you don't meal prep. So let's say, so Monday through Friday, and for those lunches you keep a track of every lunch you buy. $10 on Monday, 20 on Tuesday, 10 on Wednesday, 5 on Thursday, because of 4 for 4, right? and whatever. And then you add them all up, divide by how many times you ate out for lunch, and that will be your average of what you spend for lunch. So it's stuff like that. This average can help you in other components of life. But all right, class. So that was the first lesson. Are there any questions on 2.5 real quick? Any questions? Yeah, y'all feel better with PEMDAS when it comes to positive and negative numbers, class?
I know I
I got
came.
it. Oh, sorry.
My bad. I know I came late to class because I had some issues, but I wrote down like a few what when I logged into class and what we did. I got a gist of what was doing today.
Oh,
So
okay. Did you want me to go back to the slides so you can take pictures, or are you gonna wait for the YouTube video to get the notes? Or and you remember, you can also ask Savannah for Joan at the end of class, or send her a message right now in the chat for her email, and you can send her an email and she can send you the pictures of the notes you missed, or however you want to do it, Jacob. But just know I will be uploading the lecture on YouTube, okay?
you have a YouTube. What's the thing?
If you go to Canvas, Jacob, I sent you after class, you can check your Canvas email. Last night at 11, I sent you an email with the links for the other lectures. And then I'll be sending another email later today once I upload this lecture to YouTube.
Okay.
And then you can just subscribe to my channel so you can always see like you get notification when I upload a video, so you can just go on there and like in case you need to watch something again to get the notes again or etc. Whatever you need it for.
Okay. All right. Appreciate it.
No, anytime, Jacob. And then Justin, you were saying?
Well, I was saying, you asked if we were comfortable, and I was saying, I think, speaking for myself, I'll just have to keep practicing by myself with that repetition and all that, because I'm kind of noticing it. This makes sense. Let's
Now
just
that
say I've gotten angry. Oh, sorry, go ahead.
no, that's the key, Justin. If you're able to see me do the math and see me do the steps, and you're comfortable and you're following me and you understand what I'm doing, that's progress.
Take your
Now,
word.
from there, from that mindset, if you're able to see, okay, if you're able to follow me and understand my steps, then the next step you have to do is continue to practice until you're able to build that same intuition and comfort for when you do it.
Yeah,
And
that does make sense.
then from there, so my biggest thing, so when you practice, I will recommend practice. What this is my tip, not just to Justin, but to all of you guys. When I first went to college when I was 18, I didn't feel like my high school prepared me. Like I'm gonna be honest, like my high school
Yeah.
was crap. But I'm not, it's whatever. I'm not bitter about it. What I did is I'm not gonna dread on my past, but focus on me and my future. So every time I had homework, guys, I will go to the math lab and I would text my friends who I met in the class, and I'll say, hey, I'm going to math lab from 12 to 2 and everyone want to join me. And I would go if no one went, but people ended up coming with me because they wanted to work together. And then whenever we had questions on the homework, we'll sign up for the tutor. The tutor will come explain it to all of us, and then we'll move on with the homework. And then say someone else got trouble with another problem, they'll go ahead and put it in and ask the tutor for help, and then we'll listen to that explanation too. And we kept doing that until we started getting more confident and comfortable. So I encourage you guys to utilize your resources, okay? I know life can be hard balancing school and work and family life, a social life. It's exhausting, but it is possible, okay? So I don't mean to ramble on. All right, guys. Let's go ahead and move on to the next section. I normally do give a break, but I'm afraid of time. So I'm actually gonna go ahead and get started with the next slide. And then if we finish early, I will dismiss class early. Just because I do not want to not finish this lecture. I like to keep my classes uniform though. Is that a good deal, class? If we finish early, I dismiss early.
Sure, that works.
Okay.
Yes, sir.
All right. All right. So let's get into it. I'm gonna go ahead and give you guys about 3 minutes to copy this slide, and then we'll move on. Or I'll ask if y'all need more time. We're in 2.6 now. Now we're officially starting to learn how to solve equations. All we've done so far is learn about exponents and order of operations and how to simplify expressions and how to plug in numbers and simplify that. Now we're gonna take those same skills and develop our solving equation skills. So today's lesson in 2.6 is we're gonna solve equations using the addition and multiplication properties. And I'll go ahead and I'll read this definition once I'm done with the timer.
So on this problem, this short little problem, you do the opposite of 5, right? So it
And what
goes
do
to -5. So you subtract, that cancels out, and it's 9 minus 5. So you get 4. So x equals 4.
There you go, Jacob. There you go, sir. That's what's up. That is pretty much what we're gonna be focusing on today. Yeah, good. So today's lesson in this section should be a piece of cake for you, Jacob, when you do the homework. All right, so let's take a look at this real quick. So remember, this is an elementary algebra class, so I do apologize if you see me like talk a lot about a basic problem, but I really want to help build your confidence in yourself and in your skills, guys. And I'm gonna take my time with these just so you can fully understand these, so you can be successful in this class and when you leave from here, okay? So let's take a look at the statement. So now we know an equation is a statement. As a statement like 5 plus 2 equals 7, they're called equations. An equation is pretty much of the form, it's an expression equaling another expression. So in every equation, so now can someone tell me the difference from an equation to an expression? Seeing this? What's the one biggest difference between an equation and an expression? Let's see if I have any.
You're trying to solve for x.
So we're trying to solve for x. That's true. That is very correct. That is very correct. We are trying to solve for x or the variable. But what's
Not
one?
like you're reversing it, if that makes sense.
So what's one genuine difference? So if you look at 2.5, these are expressions here. So those are expressions. These are expressions.
The equal sign.
The equal sign. Thank you. Thank you. Thank you. So remember, if you see the problem have an equal sign in the problem, we know equation. If there is no equal sign there, if we have to put an equal sign, if you added it, then more likely it's an expression. All right, let's go ahead. Would anyone like more time on this slide to write before I move on, class? Anyone need more time? Speak now or forever hold your truth. Excuse me. All right, let's move on. Here is your helpful hint, guys. And example one. Example one's pretty simple. We've done it before, but I did want to include it as a reminder. So I'm gonna give you about 3 minutes to write the helpful hint and example one. In class, we have gone over an example like example one. So please get started on it after if you finish writing down the helpful hint in example one. And if you finish the example, work on the practice problem. And if you're comfortable with what it's asking, if not, then please wait for the timer after you wrote it and wait for my explanation. All right, let's take a look at example one. Is asking us to determine whether -1 is a solution of the equation 3y plus 1 equals 3. Now, we're not solving this class. Don't, if you solved it, that's great. That's what, because remember, with math, there's more than just one component. Solving is one thing, checking if that's an answer is another thing. So if you read this, what do we do? What do we do with that -1? Can anyone share with the class what the process is?
Yes, it's a solution
How'd you get that, sir?
because I plugged in -2 with the x.
Oh, you're talking about that. Oh, you finished the practice problem too?
We're supposed. Oh, I didn't do the example. Oh, my bad.
No. If you got the practice, so you said the practice is a solution?
Yeah.
Okay, cool. So yes, it's a solution for the practice. Let me write that down. Let's go ahead and let me finish working out the example, but good job. Let's look at the example. So plug in -1 for y, right? Plus 1 equals 3 with a question mark on top, right? Because we don't know. 3 times -1 is -3 plus 1 equal 3. -3 plus 1 is -2 equals 3. Is that true or false? It's false. When it's false, guys, what statement do we write when it's false?
All statement?
If it's a false statement, if when we plug in the solution and we get a false, what do we write?
No, it's not a solution.
There you go. No, it's not a solution. Thank you. All right. Now, Jacob did get you finished the practice, guys. Does anyone in the class need the time to do their practice problem, class?
Yeah, I think I was close onto it, but then kind of got sidetracked. So yeah, a little more time could help.
Okay, would you like 1 minute or 2 minutes?
2, just to be safe.
All right. There's a 2-minute timer on the practice problem. Make sure you have your own work, guys. Yes, I put Jacob's answer, but that's just because he told me. So y'all need to check if it's yes or no for you. Can you tell me yes or no confidently? And in math, you always kind of want to have justification for your answers. Like you want to know, like you want to be able to say, like here, you can tell me yes or no and show me why it's yes or no. Yeah, oh, I got a true statement, so it's yeah, it is. Or I know it's false, so it's not a solution. You got to be very confident and comfortable. Okay, cool. Excellent. Awesome. I'm gonna go ahead and stop the timer. All right. Any questions on an example one or practice one class? Any questions whatsoever? All right, let's move on. Now, here is the addition property class. I included it in the notes because this is not the only math class you need. You're in this class so you can enroll in the next math class that you need for your degree. And in the other class, it's going to be more advanced. They're going to expect you to know this property. They're going to expect you to know how to solve equations. They're going to expect you to know PEMDAS. They're going to expect you to, they're not going to re-explain things unless you like ask them to. And they even then they may not even tell you. I can tell you right now, had a lot of math professors in the past where I would ask a question and they would legit respond to me. You should already know that. Next question. And I was just kind of like, oh, this is awkward. Did he just tell me that in front of everybody? Like, I was just like, okay, well, whatever,
X equals 1.
Excellent, excellent. So I'm gonna ask you guys, since you got the answer, Jacob, you can tell me what to write. How did you do it? So how did you get the one? What was the step that you took to get X by itself, sir?
Well, to cancel to get, because okay, let me see. So you got -2. You're gonna want to cancel that out by doing the opposite. So that's +2. And
Okay.
that cancels out. And whatever you do on that side, you have to do to the other side.
And when you say other side, you mean the other side of what, sir?
The equal sign.
There you go. Excellent. Okay, we do that. Okay. And what happens to my choose?
Those cancel out.
And what do I bring down?
So that leaves X by itself.
X by itself. Good. And now on the right side, what do we do here?
So you're gonna do it like you're doing a banking thing. So you go -1. You have to add 2.
We
to your
added
bank.
$2. Yeah, we added $2 to our bank. So now how much do we have or owe?
That's, you have $1 in your bank account.
Excellent, sir. Excellent, excellent. So what I want to talk about this property, what this, let me read this property to you so y'all know what it's reading in. So the addition property of equality says that let A, B, C represent numbers, then A equals B and A plus C equals B plus C are equivalent equations. Or A minus C, B minus C are also equivalent equation. What this property is saying, class, is that if we can add a number to one side and we add it to the other side, the equation does not change. Because we don't want to change the equation. We want to solve it. And we solve it by manipulating the numbers we see by doing the opposite operation. The opposite of negative or minus is what?
Yep. Yeah. Plus positive. There we
Good.
go.
What's the opposite of multiplication?
Division.
Good, good. So on, right? Now I want to show you a technique that I showed my last semester, and a lot of them appreciated it because it helped them on their assignments. So whenever we solve equations, class, and this is for easy equations and also difficult equations. So this tool that I'm about to show you will be something you can use outside of my class as well in the other class that you're going to be taking. So it's called Check Your Work. And I'm sure you probably had middle school or high school teachers try to do this to you, and you probably didn't care back then. But this is a great tool to utilize. And so what does that mean, right? How do you check your answer? Because how many times have you ever had you've done a problem in class, whether it be in college or high school, and you weren't too sure in your answers, right? So what would you do? Always ask the teacher, right? Or ask the smart kid, or ask someone that around you that wasn't you to see if you did it right or wrong, right? That was me. But there's a way to check your work. The way you check is you plug in the answer that you found, you plug in the solution that you found in the original equation for X. So then we get 1 minus 2 equal question mark -1. So it's pretty much what we did here. We're determining if it's a solution, right? We're plugging it into the original. It's the same thing as example 1, but we're including it and solving it. So that way we can check, is this the correct solution? Now, number 2, this example is pretty simple, so we know we're right. But this tool, if we start now early, when the equations get more challenging or more difficult, this process will keep us from making more mistakes. Does that make sense, class?
Yes.
All right.
Yeah,
So 1 minus 2 is -1 equals -1. That's what? That's true. So this is the correct solution. So if you were to turn in this problem for a grade, you would get it correct, 100 on it. All right. Let's take a look at two more examples, guys. I'm gonna give you 1 minute to copy example 3 and 4. If you're comfortable solving these, please go ahead. Do not wait for me. But if you are struggling or need more help, just wait for the timer to go off for me to explain it. All right, that was a 1 minute timer. Let's go ahead and look at example 3, class. So it wants us to solve -8 equals n plus 1. Now, another math fact that I want to share with you that I did not learn till I was in college is if you have an equation A equals B, that is equivalent to B equals A. So what that means is if you don't like the way the equation is originally set up, you can flip it. So instead of having the number by itself on the left side, I can rewrite it as n plus 1 equals -8. And it means the same thing. And I know some of you are, why is he doing that? Why does that matter? You know, blah, blah, blah. Well, for me, I like to have the variables on the left-hand side. It makes solving smoother and easier and less confusing.
I got -9.
-9, excellent. Thank you, Jacob. You want to share with the class
Same here.
what's the step that we took to get n by itself, class? What did y'all do?
Subtract 1.
Subtract 1, and then what we do to one side, we do to the other. Bring down the n. So -8, we owe the bank 8, but we spent $1 because the ice cream it came by, so we still owe the bank $9. Now we want to make sure we checked it, right, to make sure we're good. So then we check. And then we get -8 equals -9 plus 1 question mark. Then we get -8 equals -8, which is true. So this is the solution, class. All right, let's go ahead and take a look at example 4. Solve. What do we notice about this example? What's already by itself?
X, so we have to do the inside.
That we
Right
just
there.
gotta do the other side. We just gotta add and subtract. So -60, we owe the bank 60. We deposit $4, so now we owe $56. And we deposit $10, so we only owed how much? $46. So we're gonna go ahead and check our solution, check our work. Then we get -46 equals -60 plus 4 plus 10. And then we get -46 equals -46, which is true. Any questions on examples 3 and 4 before you work on your own practice problems class? All right, no questions, guys. So I'm gonna go ahead and put up to your practice problems. I'm gonna go ahead and give you guys 3 minutes, 1 minute for each. And if y'all need more time, I'll add it. And y'all may put your solution in the chat. Your 3-minute timer starts now. I'm gonna use the restroom real quick. I'll be back.
Hey, what y'all get for 3?
I have not gotten to it yet, so I can't tell you.
I got -12 for 3.
I got -93.
I got 12 as well. I'm not too sure.
I got
Because
-12.
equals because it gets 88 plus 90 plus -100.
All right, class, I'm back. All right. Any questions so far in any of these practice problems, class? Sorry, I came in and I heard someone say that they got -12 for 3, so I wrote it down.
Okay, I see what I did wrong. Yeah, I got -12.
Good, good, good. Anyone have any questions for 1 and 2? Okay, I felt pretty good about those.
Yeah, just number 3 just didn't look nice for that parentheses.
Yeah, right. But now after the last lesson, do y'all know what to do when you see that parentheses and the plus and minus? Or plus and negative?
Do you mind just like reviewing all three just to make sure I got it right?
Yeah, I do not mind at
Especially the
all.
first two.
I do not mind, Sophia. I'd rather y'all tell me than me just do it because I don't want to be that teacher. But no, I got you, Sophia. All right.
Thank you.
Let's take a look at number 1 class. So we have y minus 6 equals -2. We draw the line down the equal sign. Now remember, when solving, the objective is to get the variable by itself. Now, when solving the variable by itself, you do the opposite operation, right? So the opposite of -6 class, what's the opposite of -6? Can someone share, either unmuting or typing it out?
Plus 6.
+6. And what we do to one side, we do to the other, right? So that cancels out and we bring down the y. -2 plus 6. So we owe 2, but we deposit 6. So now we have $4. Now, if you're not sure that's the right answer, then check your work, right? If you're not 100% confident, then you check. You plug in this y in the original problem. So then we get 4 minus 6 equals -2 question mark. Plug in 4 minus 6 in your calculator, and then you would get -2 equals -2. That's true. So therefore, what can we say about 4 class? That 4 is what? Remember, these are practice problems. This was y'all's responsibility. So I'm working them out, but I need y'all to participate. So if we got a true statement for the check, what can we conclude about the solution? Can we say it is or it isn't?
It is.
There you go. Excellent. So now let's look at number 2. So we have z -2 equals z plus 8. Remember the property I showed you? We can switch the order around if we don't like the way it is. So now we want to get z by itself, class. Can someone tell me the step that we will take to get z by itself?
Subtract 8.
Subtract
No, left side.
8 and on both sides, that's correct. So then we get z equals -2 minus 10, which I mean -8 minus 8, which is -10. Then we have to check, right? Well, not that we have to check, but I want you to check. This is a good habit to start doing early on. So I would do -2 equals question mark -10 plus 8. And then we'll simplify that in the calculator. You get -2 equals -2, which is true. And this is a correct solution. Now for equation 3 class, x is already by itself. So what do we have to do essentially for problem 3? We have to just simplify the right side, right? And we simplify using PEMDAS. So we're adding, but what's going on here in this third part? What's happening with this plus minus class? What are we really doing?
Just adding.
When we plus and when we're adding a negative though, what happens when
Subtracting.
we're subtracting? Okay, good. So now we add and subtract from left to right. So you owe the bank 2, but we deposited how much? 90. So when they take the $2 we owed them, we get 88. So then we get 88 minus 100. So we had $88 in our account, but we spent 100. So we owe the bank $12 and we're done. And then you check. And then we get -12 equals all of this, which equals to -12 equals -12, which is true. Any questions on any of the steps we took today in this example?
No, sir.
Justin, what question was that? It cancels it to subtraction. Which part are you talking about, sir?
Oh, that was before you that was before you wrote it down on 3.
Ah, okay, so you're good?
Yeah. Yeah.
Okay, good, good, good. All right, let's go ahead and move. And Sophia, were you good with the explanations, ma'am, or any other questions?
No, I
Yeah.
got it. Thank
Good,
you.
good. No, anytime, ma'am. Let's go ahead and move on. All right, now we have another property, guys, multiplication property, and we have a couple of equations to go. I'm gonna go ahead and give you about 2 minutes or 2.5 minutes to copy this stuff down. And then let's get started on example 5. So the multiplication property of equality says, let A, B, and C represent numbers and let C not equal to 0. Then A equals B is the same thing as A times C equals B times C. They're equivalent equations. It's the same thing as dividing by C on both sides. It's also equivalent. What this property allows us to do now, it tells us that we can multiply something on one side and do to the other and not change the equation. Because we don't, if we added 1, like +1 over here on 5x, that's no longer the same equation because we did not add a +1 here. Remember, the key to equations is I want you to think about it like a weight scale, a balance scale. If to keep it balanced, what you do to one side, we always have to do to the other, whether it be add weight or taking away the weight.
So side by side.
Yeah, so let's take a look at example 5. -5x equals 15. Now remember the very first lesson or the second lesson, what happens when we have a number and letter next to each other? What operation is going on?
Multiplication.
And now, so we want to get x alone. So what's the opposite of multiplying -5?
Dividing.
Dividing. So we're going to divide both sides by -5. What we do to one side, we do to the other. And then I get x is equal to, right? Because -5 over -5 becomes a big 1. And then 1x is the same thing as x. So you don't have to write the 1. 15 divided by -5 is a -3. So that is the solution I have so far, -3. I want to test it out, right? Because I know how to check, because that's a tool that I know. So now I'll plug it in. So it'll be -5 parentheses, -3 equals 15 question mark. Two negatives we know makes a positive. 15 equals 15 is true. So that tells me that -3 is the correct solution, class. What questions do we have on example 5, whether it be the solving or the checking?
So if it's a problem like this on the left side, it's typically what you divide cancels it out. And then that's what you divide on the right to get the answer.
Correct.
Okay.
Sir,
Oh, we
what?
also have to do square roots, sir, or no?
So the square root will happen at the, so the way it works this class is I teach you the basic steps, the basic solving equations, and then I work the equations that I pretty much teach you how to solve different equations as we move on the class. So maybe later on in a different chapter section, I'll teach you harder equations and whatnot. And I think towards the end, we do square root equations, possibly. If we don't touch it this semester, then you will definitely touch it on next semester.
Why is it -5?
Why are we dividing by -5? Because
Yeah.
well, remember the original equation, what's next to the x?
-5.
5. So and now remember our objective when solving an equation is we want to get what by itself?
The x.
The x, right? So if I divided by a +5, Jacob, if I did -5 divided by +5, if I did -5 divided by +5, that would still give me a -1. And I don't want negative x, right? I want just x. So that's why I divided by what was next to x. Because remember when we divide the same thing, -5, it just gives us
So
a 1.
so shouldn't it be the opposite of -5? So shouldn't it be +5 and you'll still have a positive x?
Ah, so let me correct you on that. So it's not that we're looking for the we're only, it will be a +5 if we were subtracting 5, if it was like -5, but we're multiplying the number to x, sir. So when we're multiplying, remember to manipulate equations, we have to do the opposite operation. So I understand you when you're saying that it is a -5, it should be a +5. But that's if we were subtracting a 5. We would
Or
only,
add. Okay.
but we're not now. This one, remember, is different now because now the number and letter are next to each other. Which what operation does that imply, Jacob, when we have a number next to a letter? They're being what? When we have a number letter, they're being,
Does that mean it's multiplication?
it is
Like when
multiplication.
when a number is next to a letter,
Yep, they're being
Oh, yeah.
multiplied.
but if there
Yeah.
wasn't a letter, then it would be +5.
That is correct. So if it was like this, if it was -5 plus x, if x was already by itself and we just wanted to move the -5 over, then we do a +5.
Oh, okay. I get it. So it's -5 then? It's the same?
Yeah, it's the same thing because since it's multiplying and we know the opposite of multiplication is division, so that's why we divide by the same number so that x can become by itself. That's why we do -5 divided by -5 because that gives us a +1, which is just the same thing as x.
Okay.
Great questions, by the way. And then
But you
you'll
have to
be,
carry the sign over.
yes, we
basically.
carry the sign over. That is correct. And it's okay. We will get through it with the other examples I'm gonna do. And then the practice problems, you'll show me that it's clicking, right? And if it's not clicking, then you ask what's confusing you, and we're here to fix that, okay? All right, these are great questions, guys. Are there any other questions before I move on to the next examples? All right, example 6 and 7. And we're gonna give you 1 minute to copy these down. All right, let's take a look at the example 6 class. We have -27 equals 3y. Me being the OCD guy that I am, I'm gonna flip it, right? Because I don't like the letter being on the other side. That's just who I am. Now, can someone share with us? We have 3y equals -27. Can someone tell us what is the one step we're gonna do to get y by itself? Now remember, we have
By
to
3.
divide 3. Excellent. We have to remember And what we do to one side, we do to the,
Other.
and then what's negative 27 divided by 3?
-9.
Negative
Negative
9.
9.
And then we.
Oh, shit.
And then remember, we can check, guys. Remember, you know how to check to see, am I right? Did I get this right? Or was I guessing, So you plug it into the original equation, work it out. You get negative 27 on the right and on the left. That's a true statement. So we did get the correct solution. Any questions on the solving or the checking?
So it's basically the same thing as the previous problems, just flipped around.
There you go, exactly. And you could keep it flipped around or you can manipulate it the way I did. It's up to you. Example 7 class, negative 12x equals negative 36. Will someone actually share what we do to get x alone?
The
Divide.
same
Divide by
thing,
negative
cancel
12.
it out.
Divide by what?
Negative 12.
Negative 12.
Good. And then these two become positive, right? So we get x, right? And then two negatives become a positive. How many 12s go into 36?
3. 3.
And then let's go ahead and check, right? Because we know how to check. So then we get negative 12 parentheses 3 equals negative 36 question mark. And then we get negative 36 equals negative 36. And that's a true statement. So we are correct, class. Any questions on example 6 or 7 so far? All right, let's go ahead and well, this is the last example of this lesson, guys, the last example. And then we have one practice problem that a set of practice problems to finish off. So I'm gonna give you about a minute to copy this one down before I work it out. So we know when the number is next to the letter, like 5x or 6x or 20x, we know that's multiplication. Here in example 8, then we want to solve x over 3 equals negative 2. Can anyone tell me what operation is happening?
You multiply. You multiply.
We do multiply, Ishmael, but the question was what operation is happening with x and 3? What do we say?
Isn't that division?
It is division, and like Ishmael said, the opposite of division is
Multiplication.
multiplication. All right, good. So in case you didn't know that, you can write a little arrow over here and put like, this is dividing 3. Now you know this is dividing 3. And then the opposite of dividing 3 is multiplying 3, which we can do with the dot. And we can also draw with parentheses. What we do to one side, we do to the other. Right? These 3's are going to cancel out, right? And we're left with x. Negative 2 times 3 is negative 6, and we're done. We're going to go ahead and check this one out just to be safe. Right? It doesn't hurt. So then we have negative 6 divided by 3 equal negative 2 question mark. Negative 6 divided by 3 is negative 2 equals negative 2, which is true. And this is the correct solution. So now you've seen the opposite of dividing with multiplication. And you see me solved it and you see me checked it. Any questions or what questions we have before I put on the last set of practice problems, guys? Any questions? Because now you're going to show yourself and show me that you know how to solve equations. Ready?
So in,
Go ahead.
sorry to interrupt. So in problems like these, whenever you're multiplying, you bring the 3 like right here and you cancel that out, then bring it over, then multiply.
So it's not about, it's pretty much like think about it of them happening at the same time. I canceled out the 3's on the left side because I knew when you divide 3 and you multiply 3, that's canceling out. And then what we do to one side, we have to do to the other. That's why I
Okay.
put the multiplying 3 first on both sides. And then I simplified the left and then I simplified the right, doing
All right.
2 times 3. All right.
Cool.
All right, let's go ahead and give it a try, class. Show me if you can do it. Here's your last set of practice problems, class. Good luck. I'm not gonna give a timer just because, just because you guys are working through this. This is the last thing we're doing today. I'm gonna go ahead and do roll call, class, while you work these problems out. Can y'all still see my presentation, or do y'all see the attendance?
I see the presentation.
Okay, good, good, good. All right, remember, let me know if you're here by unmuting yourself or typing in the chat. Jacob Cox,
Here.
Aaliyah Cuevas. Is Aaliyah Cuevas here? Okay, there she is. Thank you, ma'am. Marisa Cuevas. Excellent. Alexis Esquivel. No, Alexis. Brandon Estrada.
Here.
Felicia Gonzalez.
Here.
Jose.
Here.
Wanda.
Here.
Ana Lucia.
Here.
Jacob Martinez.
I'm here, sir.
Awesome, awesome. Jolene. No, not here. Christian.
Here.
Diego. No, Diego. Ishmael.
Here, sir.
Sophia.
Here.
Marleth. Shirley.
Here.
Justin.
Present.
Excellent class. Excellent, excellent. All right. How's everyone doing for the practice problems? How are they?
Understood a little bit easier, I'd say.
Good, good, good. Were you able to solve all of them?
Yes, I wrote them pretty sloppy, but I was able to solve them, yes.
Now,
And
did you check them to see if they're correct?
Yes, and I got all negatives on them.
So like, when you say negative, do you mean like you got true statements or false?
True, wait, what?
Because when you check the solutions, Justin, you want to remember a true statement or a
course.
false statement. Remember that?
Yeah, yeah.
And then you said you checked them, the ones that you've done?
Well,
Or
kinda.
if you did not, then I recommend do it because it is a technique I'm showing you.
Sure, yeah.
It
What
is.
did you mean by negative? What do you mean by that, sir?
Oh, because Justin said negative. He said they were negative, and I was kind of, yeah, it threw me off a little bit, but I redirected with not negative, but for him to check his solutions, whether they're positive or negative, to check in the original to see if it's true or false. But if
Fair
y'all want
enough.
to know, I could tell you right now, 1 is going to be negative, 2 is going to be negative, 3 is going to be positive, and 4 is going to be negative.
Okay.
In case you, if you care to know, right? Not that you need to know, but like,
Yeah.
and if anyone would like me to work out any of these, all you have to do is ask class.
I mean, sir, I'm just checking them right now, just to make sure.
Cool, cool, cool. Excellent, excellent. You finish all 4? You just checking now?
Yes, sir. Finish off 4.
Awesome,
checking.
awesome. Awesome, awesome.
Wait, so you said 4 is gonna be a negative?
Yes.
Okay.
I'm here. We want to talk it out. Like if you want to like run it by me or like talk to me what you're doing. I don't mind.
I got 3. I don't know how I got 3.
You got 3 for number 4?
Yeah.
So, okay, so the equation says x divided by -4 equals 7, right?
But
How
see,
did, what,
I
what-
put the -4 on the left and times it canceled out. And I
good.
brought it over and did 7 times -4.
Ah, no, yeah, because you say you got 3, right? You probably did 7 minus 4 by accident. So make sure when you have the -4, it should have parentheses around it, sir. So you can see that it's actually multiplication instead of of subtracting. You know what I mean? Let me show you what I mean. You probably did 7 minus 4 because you're multiplying, but make sure you put the parentheses to remind yourself of what you're doing. Okay, sir?
Okay.
This is what
thank
you did, right? This is what happened?
Yes.
And then you subtracted by accident. It happens, dude. It happens, man. I
Because
can
in my phone calculator, I put 7 times -4, but it's still giving me 3.
Oh, woo, oh, then, oh, what calculator did you, is it your phone one or like a one
Yeah,
you
it's
bought?
my phone.
Oh,
That's why.
time to get a new phone, man. I'm just kidding.
All right. I might just get a new calculator out.
That too, that works out. Or hit up Savannah Patrol and be like, hey, miss, when can I go pick up a calculator? And she'll tell you the details.
Okay. I'll see if I have time.
No, I feel you, man. I feel you. I know. I know. Like, I went to campus yesterday to. Hey, has anyone been on campus and can tell me like if there's bike racks for people who have bikes?
There is, yeah.
Okay, thank you, Jess.
I finished the practice problems.
Excellent,
Okay,
excellent.
me too. I think I got it right now.
Okay, good, good, good. Does anyone need me to work any of them out? Does anyone want to share with what they got for number 1, for number 2?
I got -6 for 1,
I also got
-4 for
-2
2.
for 1.
9 for 3, and -28
-28
for
for
4.
4.
Okay, did anyone get anything different from these?
Oh, I got the same.
Good, 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 good. Does anyone like got something different? Doesn't know why they got something different and would like some explanations? Anyone? This is the time to ask. All right, since I have no questions, guys, I'm gonna go ahead and stop recording.